string theory reimagines the point particles and fields of quantum field theory as tiny, one-dimensional oscillating strings along with some other sort of fundamentalia. But what people allege is that it's unfalsifiable, in part because there are currently no conceivable experiments that could be run to test it. And what I am wondering is whether or not you think, a la Popper, that this should preclude us from viewing string theory as science.
So the two reasons that something might be unfalsifiable. One is that it's the theory itself is so developed so that no conceivable experiment.
Thanks for qualifying my word conceivable. I mean, you used it much better than I did. I should have said no practical experiment can be done.
No conceivable experiment could falsify it. If that is really the case, then it's not science. But if there's no experiment that can be done now that can't falsify it, that doesn't mean that if you work on the theory and you develop things and you develop new technology and so on, you couldn't falsify it. There are all sorts of hypotheses in cosmology that can't be falsified now, but are very interesting and important, and there were ones at times which couldn't be falsified and later were able to be falsified or I'm not sure verified is the right word, but they passed tests, falsification tests. So that's a very important distinction. As far as I understand, I'm no expert in string theory. I understand it to an extent, but I'm no expert in it, far from it. There's a problem within the foundations of physics that's super, super important. And that is that the two basic fundamental theories, really one really, really fundamental theory, and that's quantum field theory. And then there's an account of space-time that's general relativity. And it's basically the theory within cosmology is mostly done and stuff in astronomy where strong gravitational fields are involved. But it's definitely the structure of space-time. But these theories do not fit together very well. And this is a question of how to make them compatible with each other. And there are a number of ideas floating around. Have you done Carlo Rovelli, actually?
I'd love to speak with Carlo, but
Carlo's going to be around starting in October.
Oh, really?
Giving a bunch of lectures at Princeton, right? So he has an approach, not string theory, but different kind of approach, and a number of other ideas that are around. And I think at this point, this is such a tough, difficult, interesting problem. Let people think about it. I mean, it would be ridiculous for someone to say, stop thinking about it because you can't falsify it now. And if there are people who say that, screw them.